Hey everybody, welcome to Algebra 1, Section 6.2, the substitution method. In our last lesson on the graphing method, we learned about systems of equations, and the whole point is that you've got two equations that have two variables in them. And so the whole point of what we're trying to do is to figure out both of the variables, usually x and y. So let's go ahead and learn a second way of doing this, and this one doesn't have graphing at all. This is all going to be algebra based. I like this one a little bit better than the graphing method. So here's the substitution method. By the end of this lesson, you should be able to know how to use systems of equations by the substitution method. You also need to be able to discern if there's no solution or infinite number of solutions. And you need to use the substitution method in some story problems. So for the substitution method, there's 4 steps. So let's check out those 4 steps. Let's say we have a system of equations here, where I've got 2 equations and each equation has 2 variables. So step 1 is get one of the variables by itself. So if you check out the second equation doesn't have a coefficient on the x. So that's going to be very easy to get by itself. All I have to do is subtract the 5y from both sides. So when I do that, you can see I get the equation x equals -1 minus 5y. So usually one of the variables won't have a coefficient. And that's the variable that you want to get by itself. It doesn't matter which variable. I could have used the top x, the top y, the bottom x, the bottom y. But because that bottom x did not have a coefficient, that's the variable I got by itself. So now that I have that x all by itself, here's what I'm going to do with it. I'm going to take that expression. I'm going to use the fact that x equals -1 minus 5y. Those two things are the exact same. So the idea behind substitution is that you take something out and put something just as good in its place. So what I'm going to do is I'm going to go to the other equation, the 2x minus 3y equals 11, and where the x is, I'm going to take that x out, and I'm going to put something just as good in its place. I'm going to take that -1 minus 5y and put it in there. So here you can see that I did that. I even tried to color code it to make it a little bit easier to understand what I did. So I took 2x minus 3y equals 11. I took the x out, and I put that -1 minus 5y in its place. Okay? That's the second step. There's not a whole lot to it, but that's the essence of the substitution method. Take that variable out, put that other expression in its place. So when I do that, I now have this mega equation. But the nice thing about it is, if you take a look at that equation, I don't have x anymore. All I have is y. So what I'm going to do now is I'm going to solve this mega equation. So you can see my steps here. I distributed the 2, and so I got -2 minus 10y. And then I brought down the -3y equals 11. Now that's a big thing that a lot of people do, is once they distribute, they kind of tend to ignore what's left in the equation. Okay? So don't do that. Make sure if you've got -3y, make sure you bring it down. Next thing I did was I collected like terms. So if I have -10y and -3y, that makes -13y. And after I distribute and collect like terms, it looks like a very easy equation now. All I have is -2 minus 13y equals 11. So I add 2 to both sides and get -13y equals 13. Divide by -13 and I get y equals -1. So by the end of the third step, you should have figured out one of your variables. Okay? So step 1 is get a variable by itself. Step 2, take out that variable and plug in that expression into the other equation. Step 3 is just work out the mega equation that you just created in step 2. But remember, in order to do systems of equations, you need both variables. So I now have y, I still need x. So that's step 4, is I'm going to take the fact that y equals -1, and I'm going to plug that back into one of my original equations. So I happen to choose the x plus 5y equals -1. I could have chosen the 2x minus 3y equals 11, but I took the x plus 5y equals -1, and where the y used to be, I plugged in -1. So now I have x minus 5 equals -1, and then I get the x value of 4. Now, if you recall, when we solved the answer, or solved systems of equations using the graphing method, our answer was a coordinate. It was where our two lines met. And so it was x comma y as our final answer. I want you to do the same thing here. So our final answer here would be 4 comma negative 1. Okay, so let's go ahead and see a few other examples, and let's work those out, okay, using these same 4 steps. All right, so here we have a few examples, and let's work it out using the 4 steps that we just learned in the previous slide. So step 1 is get a variable all by itself. Well, if you take a look at this first equation, y is already by itself. So sometimes step 1 is done for us already. So what I'm going to do now is I'm going to take that other equation. So negative 8x plus 2y equals 2. And here's the whole idea behind the substitution method. Since y is the same thing as x plus 4, I'm going to take y out, and in its place, I'm going to put that x plus 4. Okay? So that's step 2. That's the essence of the substitution method. You took out the y, and you put in x plus 4. Now, a good double check here is that I should have all the same variable now. After step 2, if I still have both x and y, you've done something wrong. Okay? So now I've got one variable, one equation. So now step 3, let's work out this mega equation. Let's distribute the 2. So that's 2x plus 8. And then after we distribute, we always collect like terms. So negative 8 and positive 2 makes a negative 6x. Next thing I can do is I can subtract 6 from both sides, and I get, subtract 8 from both sides, and I get negative 6. Divide both sides by negative 6, and I get x equals 1. So after your third step, you should have one of your variables. Now, last thing I want to do is I want to take that and I want to plug it back into one of the original equations. So I'm going to choose y equals x plus 4. I could use the other one, but y is already by itself, and that's what I'm going to try to solve for in step 4. So y equals x plus 4. I'm going to take out x, and in its place, I'm going to put that 1. So now I've got y equals 1 plus 4. Well, that's just 5. So my final answer there is x comma y, so 1 comma 5. That's my final answer. Let's take a look at a second example. So step 1, get a variable by itself. Now, which of these 4 variables, the top x, the top y, the bottom x, the bottom y, which one looks to be the easiest to get by itself? Well, I'm going to say this bottom y, because it doesn't have a coefficient. So I'm going to subtract 7x from both sides. And so now I have y equals negative 13 minus 7x. Okay, so step 1 is done. I got a variable by itself. Again, it doesn't matter which variable you choose, but I recommend choosing the easiest one, and that's the one without a coefficient. So now, step 2 says that we're going to take the other equation, make sure it's the other equation, so negative 4x plus 5y equals 13. Now here's the whole idea behind the substitution method, is that I'm going to take y out, and in its place, I'm going to put that negative 13 minus 7x. Okay, so step 2 is now done. Now I need to solve this mega equation. So let's distribute that 5. So 5 times negative 13 is negative 65. 5 times negative 7 is negative 35. X. After you distribute, you collect like terms. So negative 4 and a negative 35 make a negative 39x. I'll bring down the negative 65. Let's add 65 to both sides. So when I do that, I get 78. And let's divide by negative 39. And I get x equals 2. Now here's a very common algebra mistake. Notice how I divided by negative 39 on one side, but on the other side I forgot to put that negative there. That happens a lot. And when you do something like that, just a simple mistake, that throws off our answer here for x, but then that throws off our answer for finding y as well. So one tiny mistake can throw this whole problem off. So make sure you're very aware of what you're doing. So step 4 says take the other equation. So I'll use the negative 4x plus 5y equals 13. And I will take out the x. The reason I know it's the x is because in step 3 I found x equals negative 2. So take that out and plug in that negative 2. So now I have negative 4 times negative 2. That's going to be 8 plus 5y equals 13. Subtract the 8. Divide by 5, and I get y equals 1. So final answer, my x value is negative 2. My y value is 1. So negative 2, 1 is my final answer. Okay? Let's do one more example just to work this process through. And the more you do this, the more comfortable you get with it, the easier it becomes. So, step 1, let's get one of the variables all by itself. So, of all these variables, that top y looks to be the easiest to get by itself. So I will add 3x to both sides, and I get y equals 7 plus 3x. Step 2, let's take our other equation, make sure it's the other equation. So negative 4x plus 4y equals negative 12. And here's the idea. Since y is the same as 7 plus 3x, you take out the y and you put something just as good in its place, which would be 7 plus 3x. And that's step 2. Step 3, let's distribute, collect like terms. So negative 4x plus 28. And then 4 times 3x is plus 12x equals negative 12. Find our like terms here. I have a negative 4x and a positive 12x. So that makes 8x plus 28. Subtract the 28 from both sides. I get 8x equals negative 40. Divide both sides by 8, and shazam, x equals negative 5. Okay? So now that we have that, step 3 is done. We now know what x is. Take one of our original equations. Actually, can I let you in on a little secret here? Rather than go back to one of our originals, it's also a good idea to take what you got from step 1 and plug it in there. The reason is, step 4, I'm looking for y. And in step 1, I got y by itself already. So if you want to stick with one of the originals, you can. But a little shortcut, use what you got in step 1. and then take your answer from step 3 and plug it in there. So I will take what I got from step 1, which is y equals 7 plus 3x. But now that I know what x is, I can take that and plug in the negative 5. So I've got y equals 7, and then 3 times negative 5 is negative 15. And 7 minus 15 is negative 8. Now, just to double check, make sure that I got this answer right, which the answer is negative 5, negative 8. I can go ahead and take that coordinate and plug it into both equations and just make sure it's right. So let me use a different color for this. Let's go with let's go with black. So if I plug it in the first equation, I get negative 3 times negative 5 plus y, so plus negative 8. So 15 minus 8 equals 7. 7 equals 7. It works in the first equation. Let's plug it in the second equation and double check that. So negative 4 times negative 5 plus 4 times negative 8 equals negative 12. So negative 4 times negative 5 is 20. 4 times negative 8 is negative 32. And I get negative 12 equals negative 12. So it works there too. So I am 100% confident that the answer of negative 5, negative 8 is the right answer. Now, do you have to double check every single problem? Oh my gosh, that'd be a drag. No. But if you're ever a little unsure of yourself and you want to double check, do it. Also, if the directions say to double check it, make sure you do it then. Because on the test, it'll give you a problem and it'll say double check your answer. If you don't double check, you're losing points. Okay? So make sure you do what the directions tell you to do. Now let's take a look at a few special cases of what's going on here. So let's go ahead and work out this first one. Step 1, get one of the variables by itself. So I'll get this top y by itself. So if I subtract 3x, I get y equals 7 minus 3x. Okay, so step 2, let's go ahead and take that expression and plug it into the other equation. So I get 12x plus 4 times y. So y is the same as 7 minus 3x equals 28. Let's distribute. So 12x, and then 4 times 7 is 28, and 4 times negative 3x is negative 12x equals 28. After we distribute, we collect like terms. So I've got a positive 12x and a negative 12x. Well, a positive 12x and a negative 12x cancel each other out. Okay, so this is why this is a special case. Because I'm trying to find both x and y, and at this point, I have neither x nor y. Everything canceled out. So I have the statement 28 equals 28. So if your variables completely cancel out, there's no more variables, just stop right there. There's no need to do any more algebra. Because our answer is either going to be infinite number of solutions or no solutions at all. Okay? If you think back to our graphing section, it was infinite number of solutions when you had one line and then it was the exact same line on top of it. And it was no solution if you had one line and the other line was parallel to it and they never touched. Well, we don't have a visual here, but here's how we can tell. Take a look at this statement that we have, 28 equals 28. If that's a true statement, which it is, that means you're going to have infinite number of solutions. Okay, let's take a look at this other example. So first step is already done for us. Let's take that negative 2x plus 8 and let's plug it in for y. Let's distribute. All right, so in this case, the 6x and the 6x cancel out, and I get 24 equals 24, which is a true statement, so that's also going to be infinite number of solutions. However, if I'd gotten something like 24 equals 23, that'd be a false statement, so that would be no solution. Okay? So be aware of that. Be aware of that if your variables cancel out. And again, I'll see some people do something like, well, 6x minus 6x, well, the 6's cancel out, so it's just x. No, if you've got 6x's, and then you take away 6x's, you've got nothing there. You've got no x's. 6x minus 6x is 0. Okay? So be aware of that. Last thing. Let's talk about some word problems. How are we going to use what we just learned to figure out some real-life scenarios? So, step 1 in word problems, you read it. The Frosty ice cream shop sells sundaes for $2 and banana splits for $3. On a hot summer day, the shop sold 8 more sundaes than banana splits and made $156. So, how many banana splits and how many sundaes did they sell? So next thing I want to do is I want to figure out what my variables are. So I will say B equals banana splits. And I'm not going to say S equals sundaes because my S's look like 5s. But how about D for sundaes? So when we're dealing with two different variables, systems of equations, they give you two different realms of information. So if we reread that, so it starts talking about money, $2 for sundaes, $3 for banana splits, and then it throws in that the shop sold 8 more sundaes than banana splits. That doesn't have anything to do with money. So what we're going to do is we're going to make one equation about how many they sold, and then we're going to make one equation all about the money. So let's take a look at how many they sold. It said on a hot summer day, the shop sold 8 more sundaes than banana splits. Okay? So that means if you take the number of banana splits and then add 8 to it, that's how many sundaes there are. So that's what I'll do, is I'll say take the number of banana splits, add 8 to it, and that's the number of sundaes. There's one of my equations. Now let's start talking about money. Here they tell us that sundaes are $2 each, and banana splits are $3 each, and they sold all the stuff that they sold, and they got $156. So here's how I'm going to do this one. Sundaes are $2 each, so 2 times D, and $3 for banana splits, so 3 times B, and altogether they made $156. So those are my two equations. So now let's go ahead and do our steps that we just learned. Step 1 is done for us. I already have D by itself. So I'm going to come down to this equation, and where D is, I'm going to replace it with B plus 8. Then I'll distribute. Collect like terms. Subtract the 16. Divide by 5. And there we go. I just figured out that the number of banana splits was 28. So let's plug that into one of our equations. I'm going to choose the B plus 8. So 28 plus 8 equals the number of sundaes. So that's 36. Now, since this is a word problem, I don't want you to put 28, 36, Okay? It's a word problem. You're logically thinking it out. You don't go to someone who has an ice cream stand and say, hey, how many things did you sell? And they go, 28, 36. No, it doesn't make sense. So let's put our answer in word form. So they sold 28 banana splits and 36 sundaes. And that's my final answer. Let's do one more problem like that. At a restaurant, the cost for a breakfast taco and a small glass of milk is $2.10. The cost for 2 tacos and 3 small glasses of milk, they were thirsty, is $5.15. Which pair of equations can be used to determine T, the cost of taco, and M, the cost of a small glass of milk? So here's what I'm going to do. Here, the 2 different snapshots are one person ordered a glass of milk and a taco, and it cost $2.10. That we can make an equation out of. And then someone else ordered 2 tacos and 3 glasses of milk, and it cost $5.15. That's going to be another equation. So sometimes that's how they do the snapshots. It's here's what one person did, here's what the other person did. Figure out how much each thing cost. So for the first one, they had 1 breakfast taco and 1 glass of milk, and it was $2.10. The other person had 2 tacos and 3 small glasses of milk, and it was $5.15. So let's get one of the variables by itself. I'm looking at the second equation. Neither one of those looks good. However, in the first equation, either one of those would be fine. You can solve for T or for M. It doesn't matter. I'll just figure out the tacos first. So I will subtract M to the other side. And I get T equals 210 minus M. So let's go over to the other equation, and where T is, replace it with 210 minus M. Distribute, and I get $4.20 minus 2M plus 3M equals $5.15. Collect like terms. The negative 2M and the positive 3M just makes 1M. Subtract the $4.20 from both sides, and I get not 9.5, 0.95. So that tells me that 1 glass of milk costs 95 cents. So let's take that and let's plug it into one of our original equations, or we can use this right here. And I think that looks real easy. So T equals 210 minus 95. And I get T equals 115. So that means each taco costs $1.15. So let's put our answer in word form. Each taco costs $1.15. And each glass of milk, each glass of milk costs 95 cents. And there's my answer. So, a lot of stuff in this section. So hopefully I broke it down into a way that you can understand it. If not, email me, ask me questions in class, or if we're doing a Zoom meeting, ask during that. But I really want you to get this, okay? I hope you guys have a good one, and I will see you real soon. Take care.